Okay, so suppose I want to use the mathematical functions in Matlab. How can I use all the mathematical functions in the Matlab, right? Suppose I need to write an expression and compute the expression y equals to e to the power minus a sine x plus 20 under root y, and I have given the values of a and x as well. Okay, so how I will write it on the Matlab? First of all, I will write the values what are assigned, right? Suppose I am just assigning the values a equals to 6, and I am writing the semicolon, x equals to 4 semicolon, and y equals to, where's y, equals to 9, right? And semicolon. Now I will write the expression. See, I am ending everything with the semicolon so that it does not come, it suppress the output, right? So I am writing the expression now. Y equals to, I said 5 e to the power minus a. So how I am going to write is 5 multiply exponential e. So I will denote it with exponential bracket minus a, right? Then I need to multiply it with sine x. So I'm doing it here like this. So it is sine x. And then I need to add 20 under root y. So it is 20 under root y. That means I'm putting the asterisk sign, and under root means I will write SQRT and y. So I will write like this, and let's see what the answer it is giving. Now I am not ending it with a semicolon because I need the answer. So answer is 59.9906. So it has computed all this result. Okay, now suppose I want to take log of any number. So there is mathematical expression log. Suppose I want to take log of 20, then the answer is 2.9957. Suppose I want to take log base 10. So what I will write, it is log 10, and then it's a number 20, and then the answer is this one, right? Suppose I want to write cos pi by 4. So I will write cos. So pi is denoted by pi in this here divided by 4. So what is the answer? Answer I am getting this, right? So yeah, so these are some of the mathematical expressions we can use. We can use the function 10x. Suppose I want to write 10, what's that value? So this is the value. We can use log 10. We can use signum function, we can use round, we can use remainder after division, and we can use angle, complex conjugate, maximum, minimum. These are all the mathematical functions we can use in the Matlab window. Now the most important topic is how to plot the curve. So for this I am just clearing the screen, clear, and now I will use new script. Why I have used this new script now? Because I want to see the output, right? So I'm just using the new script, and I will save my program in a Matlab file, right? Now just take a very basic example. Suppose the value of x equals to, I want to write 1 2 3 4 5 6 7. We can give any values you want to, right? I am doing the semicolon. Why? Because I want to suppress the output. I don't want the output at this stage. Now I want to plot the curve between x and y. Okay, so I am giving the value y equals to, let us say I am giving value here. So at first point I want to plot 2 4 6 8 10 and 12. Okay, and I am doing the semicolon here, and now I want to plot x comma y, right? I want to plot this. I will I will run this, but before run we need to save. Let us see how it saves. See, run, and it is asking to save this command. So I'm saving it with my name Gunj and plot, Gunj plot. So I'm saving it on my desktop. It is getting saved and it is run. Now it is showing error using plot. Vector must be the same length. Can you tell what is the error now? See, it is 1, 2, 3, 4, 5, 6, 7. That means at every x point there must be the y point, right? Now these are 7 values and it is showing 1, 2, 3, 4, 5, 6. Only 6 values. Now what I will do, I will put another value 14 here and let us see how it says. So see, it's plot and the plot is coming here, and we can just see here. So at 1 the value of y is 2. So x equals to 1 and the value is 2. At 2 it is 4. So at 2 it is 4. At 3 it is 6. So at 3 it is 6. 4 it is 8, 10, 12, 14. So this is our plot, right? So this is our first command. So this is saved. Now we want to change it. Save changes to Gunj plot vem. Yes, it is saved and it is coming here on my desktop. Here. So my program is open here. So this was my first program. Now, suppose I'm writing one program again, so I want to write a new program, new script, and I'm writing it. So it will explain the program is multiply. So basically I will write y1 equals to 2 cos x, y2 equals to cos x, and y3 equals to 0.5 cos x in the interval x is greater than equal to 0 and less than equal to 2 pi. Okay. So first of all, I will write the intervals. So x equals to, so I told you x, the value of x lies between 0 and 2 pi. So I am writing 0. Now I am writing the samples here. So sample is pi divided by 100. So these are my samples, and the value will be till 2 pi. So 2 multiply pi, right? And I am doing it with a semicolon. So basically it says the value of x is between 0 and 2 pi, and we can do the sample anything. We can do pi by 100, pi by 1000, pi by 10. The more samples we have, the more better graph we will receive. Okay. Now the three equations are y1 equals to 2 cos x. So the first equation I will write y1 equals to 2 multiply cos x, right? And I'm ending it with a semicolon. The second equation is y2 equals to cos x, and the third equation, just a semicolon here, and the third equation is y3 equals to 0.5 multiply cos x. So these are my three equations. I need to plot the curve. Okay, so I'm doing here plot. I need to plot the curve between x and y1. The first curve I want x and y1 here, right? Now this is another thing I will show you when the curve will come. So these two lines here, right? Now I want to plot the another curve between x and y2, right? And I want to show it with a single line, right? I'm writing the line. Now I want to show the another x and y3, and I want to give it with this dot, right? So this I want the curve to be like this. I will explain you these two lines, one line and two dots. What does it mean when we run our program, right? Now the next thing is I want to label the x-axis and the y-axis. So the syntax for x-axis label is x label, and I want to do it with you can say I want to denote it with x label with, you can say, function. I can write here function. So at x-axis it will write function, and for y label I want to write cosine functions. Okay, so this is my x label, y label, and then there is another thing is legend. So I will explain you what does that legend means. Legend is, so I'm writing 2 multiply cos x and then comma, so, this is cos x and then again comma, and this is 0.5 multiply cos x. So these are my legend, and then I want to say the title of this whole curve. So title title, and then I will show it with, so I'll show it is an example of multiple plots. I want to give this title to my curve, and then I want to set the x's as well, how my x's will be. So x's will be, I want to set the limits for the x's. So it is 0, and then it will show 2 pi, and it must show -3, and it must show 3. So these x's I wanted. Okay, now let's run the program. So when I will run the program, if there is any error it will show, and it will ask for saving the command. So I'm running the command and it is asking for saving it first. So I'm writing gunj multiple plots, right? So I'm saving it, save it, and then I'm running this program. So the program is run and it is coming here. You can see now. So can you see here? Yes. Can you see there are 3 plots, 1, 2, and 3. Now you can see one is one. This is one. One is here, this line. Another one is dot, because I have mentioned the dot here, and the third one is this line. So I'm just minimizing it. Yes, so basically here this thing, double, single, and these dots, right? So we can do anything, any values here. I can write for square, if I want square, if I want triangle, I can just place many values here. Now I have mentioned x label and y label. So at x-axis it is function, and at y label it is cosine function. Let's see the curve. So you can see x label it is function here, and y label it is the cosine functions, and we have done the title also. So it is an example of multiple plots. This is the title, and here on the right hand side corner you can see the legend. Now let us see the curve again. Let us see the plot. So at legend I have mentioned 2 cos x, and 0.5 cos x. That means it will show whatever curves we have plot, right? So this is basically the legend function. So you can see here it is showing, so 2 cos x with the blue line, 2 cos x with the blue line, the red one is the cos x, and the dotted one is the 0.5 cos x. Okay, So we can change the color. We can change the color of the curves. We can change it here. Suppose I want here S. Okay, let us see how does it do. See, can you see? S means square, so it will change it to here like this. Suppose I want, where's my program? Suppose I want here in this I want to change to a triangle here. Let us see how it runs now. See, this is this line now. We can just cover it and you can see that triangle here. Okay, now suppose I want to change the samples. I told you we can change the sample pi by 100. Suppose I change it to 10. Let us see what it gives. Okay, run. Look, when there are 10 samples, that means the curve it will give like this. You understand this? So the more samples, the more better the curve. Let us suppose I want to do it pi by 1000. Sorry, this sample I want, and I want to change this dot to suppose I want to change this dot to again. Okay, I must say triangle and dash dash. Let's see how it gives. Run. Wow, this is a, you can see now the sample were pi by 1000, so it's 1000 symbols. So you can see here all the curves what I am getting. So as you will do the less number of samples, it will give the less values, but if you will give the more number of samples, it will plot the curve like this. Okay, so these are basically some of the symbols we can use. Let us suppose suppose I want it write K here, and let us see, suppose I want C here. Let us see how does it do. Run. Yes, it changes the color. So I said B for black, sorry, B for blue and C for cyan color. So it changes the color. Okay, suppose I want the color to be changed as, I want my this thing. Okay, I want my this thing to be black color. So K is black color, C is cyan color. I want this to be red color. So I'm saying R. So if I say R and I'm running this one, so X and Y one plot will be red color. So see, it is red color. Do you understand now the difference? So we can just add any color, solid line, dash line, anything. So let us suppose I want to give one more example. I want to do the solid line. Solid line means single dash. Double dash means it will be a dash line. Dotted line means I'm just doing the dot again here. This will give the dot line again, but in the black color, right? Suppose I'm doing, let us see. Okay, I'm giving this and then I'm giving a dot like this. So it will be dash and dot. And if I will say none, that means it will not say any line. And we can write any symbol, like for S, I have told you it is a square. Suppose I want a cross sign. So I will write a cross function here. Okay. Suppose I want a asterisk sign. So C is for the cyan color. This sign is for the triangle. So I want a asterisk sign. So I will just say asterisk here. Suppose I want a circle sign. So I will say here circle. So circle, let us see if it takes this thing or not. So let's run it. Run. Yes, it is giving me this circle you can see, the asterisk you can see, but the samples are too many, so you cannot see it. Let's just decrease the sample. So I must say pi by 10, right? So I'm just saying pi by 10 and I'm now running the command. Now you will see the clearly. Yes. Now you can see here the asterisk sign, this sign and the circle sign. You understand? So basically we can do many signs, we can do any color, any line symbol and any marker with this plot the curve. So I hope everything is clear to you, how we can plot the curve and how we can change the lines, dotted, square, triangle, how we can change the colors and how we can change the symbols. So this is how we plot the curve in the Matlab. Thank you.